right. Now we're to some word problems that we're going to set up and then use our calculator to solve now that we know how to use our calculator. So we want to find the final amount in a word problem on exponential growth or decay. So what we want to do is we want to have our principal, which is our starting amount. We want to have the percent that it's at each year, and then we're going to raise it to the t power. Percent each year. So in this case, our original value, 28,500. Each year, the resale value decreases by 35%. We're not going to use 35% here. We're going to think about the percent that it maintains each year. So, full price is 100%. It decreases by 35%. It's going to be 65% of the value every year. So I'm going to use a 65 in there, not the 35. My time, 4 years. So I'm going to have 28,500, 0.65 caret, and the 4's on the outside of my problem then. 28,500, parenthesis, 0.65, to the 4th power. I get 5,087.428. Round to the nearest dollar, so 5,087. Whoops. Helps if I write the right answer. 5,087. So started off at 28,500. It decreased by 35% each year. So after 4 years, it's only going to be worth $5,087. The next one has to do with interest. The amount of $27,000 is borrowed for 10 years at 3.5% interest compounded annually. If the loan is paid in full at the end of that period, how much must be paid back? Now these have to be compounded annually. Later we'll talk about the compound interest formula, but the key here is this is compounded annually. We started off borrowing $27,000. Now here on my interest rate, I'm going to have the full price, 100%, plus the interest of 3.5%. So it's going to be 1.035. So when I'm doing interest, I don't lose money. I still have the money that I originally invested, plus any interest I earned. And I'm going to do that for 10 years. So 27,000, 1.035, or you could do 1 plus 0.035 to the 10th power. 27,000, 1.035 to the 10th power. 38,086.166. Round my answer to the nearest dollar then, $38,086. So I started borrowing $27,000. After 10 years, I'm going to have to pay back $38,066. 38,000. Helps if I write the right number. See, I'm trying to cheat. $38,086 is what I'm going to have to pay back. Number 12 is one of those half-life problems. I talked about the half-life when they were doing those formulas. Now we're going to do one of our own half-life problems. It says the half-life of a radioactive isotope is the time it takes for a quantity of the isotope to be reduced to half in half of its initial mass. We started with 160 grams. We are going to do a half-life, and we want to know how much is going to be left after 3 half-lives. So that's how that's going to look. So 160, it's a half-life, and since it's not a fraction, we don't need to put the 3 in parentheses, although you could if you wanted to. So 160, doing a half-life to the 3rd power. Hey, that one came out nice. 20. So I started with 160. After 1 half-life, I would be at 80. Half of 80 would give me 40. half of 40 gives me 20. So it's cut in half, cut in half, cut in half, cut in half, if I want to do it the long way.